Okay, now that we've told you some of the times when we can just use direct substitution to find limits, let's talk about some times when we can't use direct substitution. So one of the things that you saw when we talked about the video where we used the calculator table, that happened when we had a rational function and the denominator was 0. So one method that we're going to try to use for rational functions, so if it's a rational function where the denominator is 0, is first try factoring and simplifying. Then if you can plug that value in and use direct substitution, that's how you'll proceed. Then we'll see a couple where we have a square root. When we have a square root, what we're going to do is multiply the numerator and the denominator by the conjugate of the square root. And that's where we just change the sign, the plus or the minus, in between the square root and the other term. Okay, so let's go ahead and work through some examples. So here, number 1, we have the limit as x goes to 4 of x squared minus 16 over x minus 4. And obviously if we plug 4 into the denominator, we would be dividing by 0, which tells us we can't just use direct substitution. So here, this will still be the same as the limit as x goes to 4. We're going to factor x squared minus 16, which is a difference of squares. So it factors as x minus 4 and x plus 4 over x minus 4. And now, since we have these common factors, we can cancel them out. And we're left with the limit as x goes to 4 of x plus 4, which is just a polynomial. So we can plug the 4 in. We'd have 4 plus 4. And our final limit will be 8. Now, what's interesting here and what's actually going on is our original function is not defined at 4. We can't just do that canceling out. This would be one of those cases where we'd get a line with a hole in it, and the y value of that hole would be 8. So we're saying we do have a hole there, but the limit from each side, it would still be going to 8. Okay, now we're going to do one with the square roots. So see how this is like a rational function. We don't call it rational because it's not a polynomial, but it's like a fraction, and we have this value, the square root of t squared plus 9 minus 3 in the numerator. So we're going to multiply the numerator and the denominator by the square root of t squared plus 9 plus 3. So we're just changing that in-between term. And notice, if we could have just done direct substitution, we would have. We wouldn't be going through this. But since this is the limit as t goes to 0, and in the denominator we have t squared, well, we'd be dividing by 0. So we'll still have the limit as t goes to 0. Bring that with you each time. Okay, now we need to FOIL this. So our first term's the square root of t squared plus 9 times the square root of t squared plus 9 gives us t squared plus 9. Now, the reason we're choosing the conjugate are because the outside terms, 3 times the square root of t squared plus 9, and the inside terms, negative 3 times the square root of t squared plus 9, will cancel each other out. And then the last terms, negative 3 and a positive 3, gives us negative 9. All over. And the denominator we can actually leave factored like this. T squared times the square root of t squared plus 9 plus 3. Okay, so notice in the numerator we have a plus 9 and a minus 9, so those just become 0. So we have the limit as t goes to 0 of t squared over t squared times the square root of t squared plus 9 plus 3. And notice we're multiplying everything here. Everything's factored, and we have these t squared, so we can cancel out the t squareds. And we're just going to have a 1 in the numerator. So we have the limit as t goes to 0 of 1 over the square root of t squared plus 9 plus 3. And now when we plug in 0, we have 1 over the square root of 0 squared plus 9 plus 3. And if you work out the denominator, it becomes 6. So our limit is equal to 1/6. Okay, number 3 here is another rational function. The first thing you'd want to do is actually see if the denominator would be 0, because if it's not 0, you're going to waste your time by factoring and everything. So let's check. If we do 4 squared minus 3 times 4 minus 4, we do get 0, okay? So here, since it's a rational function, we're going to want to factor, so we're going to have the limit as x goes to 4. Factoring the numerator, we can pull out an x. We'll have x times x minus 4. And the denominator, we need two numbers that multiply to get negative 4 and add to get negative 3. So that'll be negative 4 and plus 1. So here we can see these cancel out. And we're left with the limit as x goes to 4 of x over x plus 1. And when we plug 4 in, we get 4 over 4 plus 1, which is 5. So our limit is 4/5. Okay, and we have one left, and it's another one with the square root. And the square root wouldn't have to be in the numerator. It could also be in the denominator, and this will work. So we're going to multiply the numerator and the denominator by the square root of 1 plus h plus 1. So when we FOIL up top, we're going to get 1 plus h. The middle two terms will cancel out, and then minus 1 all over h times the square root of 1 plus h plus 1. Okay, again, this 1 and this minus 1 cancel each other out. So here we have the limit as h goes to 0 of h over h times the square root of 1 plus h plus 1. And I'm sure you see it by now. We can cancel out these h's, and this becomes a 1 up top. So we have the limit as h goes to 0 of 1 over the square root of 1 plus h plus 1. When you plug in 0, we get 1/2. So our final limit would be 1/2. Okay, so just to recap the video, when you have a rational function and you get a 0 in the denominator, you'll factor and simplify. And if you have one of these square roots, you'll multiply the numerator and the denominator by the conjugate.